Hi guys, this is Jonathan Lambert with Maths and Stats, and in this video, one of our first videos to do with concentrating on calculus and in particular important definitions and theorems. What we're going to attempt to derive today is the fact that if a function is differentiable at a point, well then it's also continuous at that particular point. So maybe let's just state that. Okay, so let's just state this as a theorem. Okay, so the theorem that we'd like to prove is that if a function, let's say f is differentiable, okay, at a point, let's say a, okay, well then f is continuous, at a. Okay, so that's important. Okay, so this is what we want to try to prove. But before we do the proof, we're just going to maybe just because we're going to rely upon a number of different things. We're going to rely upon the definition of what a continuous function is, what it means for a function to be differentiable, and one other thing which we'll start off with is an important identity. So we have an important identity. So an important identity. Okay, and this identity states that the limit of f of x as x tends to a, if it exists, okay, as x tends to a, is equivalent in notational form to the limit of f of a plus h as h tends to 0. So that these two things are equivalent to each other, okay, just from a notational perspective. And that's actually going to be really, really important for us, is this particular fact, which we're going to use now in a few moments. Okay, that's an important identity. Also, a definition that we're going to rely upon. A definition is what it means for a function to be continuous. So what we'll actually say is this: a function f is continuous. Okay, at a point a. Okay, if the limit, okay, of f of x as x tends to a, okay, so if we get the limit of the function as x tends to this particular point, what we should get is we should get f of a, okay. In other words, if we just evaluate the function at a, that particular value should be what the evaluation of the limit as fx tends to the limit of fx as x tends to a actually becomes. So this particular limit should take on this particular value is what we mean by a function being continuous. But what is this really saying to us? Yeah, this is saying to us therefore, okay, so therefore this is really saying is that if you want to test for continuity, okay, at a point, what we need to actually show is that the limit of f of x as x tends to a, okay, minus f of a equals 0. Okay, so that's an important fact here. So this is actually a really important fact now for us, is that if we want to test to see whether whether a function is continuous, we evaluate the limit as x tends to a, we subtract from it the function evaluated at a, and what we should get is if we get 0, well then we know that the limit not that the limits that the function is actually continuous. And then finally the definition, because we need to know what we need to see to prove this particular theorem. Okay, we need to assume that the function is differentiable, and then we need to show that it's actually continuous. In other words, we're going to assume differentiability, and then we're going to show that this fact actually holds under the assumption of differentiability. So what does it mean to be differentiable? So here's our definition. Okay, it's going to be a function f is differentiable, okay, at a point a. Okay, so it's differentiable at point a if the limit, okay, of the function evaluated at a plus h minus the function evaluated at a, all divided by h as h tends to 0, is differentiable at this point a only if this limit exists. And this is our definition. This is like our definition of a function being different. This is our definition of a function being differentiable. So if this exists, okay? And we're going to assume this exists because that's what we're saying. We're assuming that the function is differentiable at a, and then what we want to show is that it's continuous. So if this exists, okay, well then we're going to label this limit as f prime, excuse me, as f prime of a, okay, because it does exist. So let's just call it f prime of a. Okay, so now let's get started. So once again, with respect to our theorem, let's just write our theorem down again. So the theorem is that if a function f is differentiable, okay, at a point A, just underlining that here, then the function f is continuous, okay.